Hi everyone, and welcome to our video on evaluating functions. Here we're just going to look at some basic examples to just make sure we're feeling okay about it. There's plenty of other examples that we can surely do from YouTube or somewhere else, but this is just short and sweet. Okay, so hopefully this gets the job done. All right, so evaluating functions. To evaluate a function, we substitute in the x value for all of the x values that we see in our function for whatever they want us to sub in. So for instance, on this number 1, they say let f of x equal 5 minus 2x squared. Find the following, f of negative 4. So we're just going to make sure we replace that x right there with whatever they put here. Okay, so f of negative 4 is equal to 5 minus 2. Make sure to use parentheses like that, and then it's still being squared. So 5 minus 2 times negative 4 squared. And then now it becomes an order of operations problem. The left side you just leave alone, you just rewrite it. And then the right side is our order of operations. So in our order of operations, let me just go ahead and put our order of operations. Remember that is, please excuse my dear Aunt Sally's loud radio, where those two are grouped. So it's parentheses first, then exponents, then multiplication or division. It's whatever comes first, left to right. So that's what that loud radio is, if you haven't heard this one before. Okay, so multiplication or division, it's just whatever's first, left to right. And then next would be addition or subtraction. Again, whichever's first on the left is what we would do, and then proceed through the right. Okay, so it doesn't mean multiplication is first if you have division. If division is the left one, then you do that first. Okay, so anyway, so I guess just real quick, like if it was 15 divided by 5 times 3, so we wouldn't do the multiplication first here. No, we would do the division first, because the division is the more left one. So this would be 3 times 3, which would be 9. Okay, so anyway, so if you did the multiplication first, we would have gotten a different answer. Okay, so on this problem, though, it doesn't affect it. Okay, so negative 4 squared would be 16. So be careful, negative 4 times negative 4 is positive 16. If you use a calculator, I mean, you could plug this all in exactly how it looks, too, to really verify. Okay, and then keep going with the order of operations. Well, it's 5. Negative 2 times 16 would be minus 32. And then now my final is negative 27. Okay, so f of negative 4 is negative 27. So that's it. So we evaluated it. Number 2, so often they're not going to just use regular old numbers, or sometimes they're not going to use regular old numbers. Here we have f of a plus 5. Okay, so that means I'm changing the x's that I see into a plus 5. So looking at my equation above, 5 minus 2, and then change the x into a plus 5. And then it's still being squared. So remember to use parentheses, and then so notice everything stayed the same. I just changed the x into a plus 5. Okay, and then like before, the left side just stays the same. The right side will go through our steps. Now this does need to be FOILed here. Let me mark it. So this will need to be FOILed. So let's set it up as minus 2 and then parentheses. Okay, so to FOIL that, it is a plus 5 squared means a plus 5 times itself. So that's why I wrote FOIL right there immediately, because of the plus inside of the square. Okay, so this is, let me write it here too. So this is where we FOIL. Now, foiling, let's go ahead. Let me use my blue again real quick. So f of a plus 5 is equal to 5 minus 2. And then we have our parentheses set up. Okay, so that, I hope, is enough room. Okay, and then when we FOIL, it's telling us take the first term right here, the a, and multiply it by the other first term. So the first times the first. So a times a is a squared. And then the o is outer, so that would be a times 5. So that would be 5a. And this is how you could do it as well, just the same way I'm doing it with my, just drawing these kind of little segments. The I in the FOIL would be the inner terms multiplied. So 5 into a would be 5a. And then this last L is multiply the last terms in each of those binomials, which would be 5 times 5 is 25. Okay, so looking at it using my colors is just really making sure this A multiplies each of those, and then this 5 multiplies each of those. All right, so now that we have that, let's still continue to set it up with our f of a plus 5 still just on the left, and then 5 minus 2. Inside this purple parentheses, we could combine these middle terms. So notice 5a and 5a are like terms, so that means they combine to be 10a, so plus 10a, and then still plus a 25 on the the last term. Okay, so this is what it looks like. Okay, and then now we would distribute, so one more distributing this negative 2 through the 3 terms. So we'd have f of a plus 5 equals 5. And then careful of the negative. So the negative distributes and it will change the signs. So minus 2a squared. Negative 2 times 10 would be negative 20 and then attach the a. Negative 2 times 25 would be negative 50. Okay, and then now one last step. We can combine our 5 and minus 50. And I'm going to put that last when we rewrite it. So I'm going to write it as f of a plus 5 is negative 2a squared minus 20a minus 45. And there's our final answer. Okay, so the order of operations really becomes these types of problems, evaluating functions, become an order of operations problem. Just remember, if you ever have parentheses being squared, if there's a plus or minus inside, make sure to do the foiling. Okay, so that's what made this problem a little worse. All right, but let's check out number 3 here. So on number 3, they're saying put this 3 over u in the x's in the function. Okay, so f of 3 over u, let me write it just a little bit over to the side there, would be 5 minus 2, and then that x, it needs to become 3 over u. And then that would be squared. Okay, and then let's keep it going. We'll just simplify a little bit. So we have 5 minus 2. And then when you square, so this does not have a plus or minus inside these parentheses being squared. That means this 2 raises each of those. Okay, so it means it's going to be 3 squared over u squared. And since we can do 3 squared, let's go ahead and do that. Okay, so far we have 5 minus 2. 3 squared is 9. And then u squared will just have to stay as u squared. Okay, and then for this next step, and it'll be our last step, I mean, I could put a 1 under the 2. So here I do have multiplication with fractions. Remember that the numerators will multiply across, so that 2 will times the 9, and then the 1 will times the u squared. And then from there, that will be our final answer. So we have f of 3 over u is 5. Now this minus is still there. 2 times 9 is 18. 1 times u squared is u squared. Oh, and let me just box that final part. Okay, so that's our final answer, the 5 minus 18 over u squared. Okay, so this is evaluating, and so I wanted to do others with letters because I'm sure we've seen these with regular numbers before more often. The ones with these letters can make us think a little bit more about what we're really doing, especially since these number ones we can plug into a calculator. Okay, but this next one, it is just numbers. Let's see how this works. Okay, because here we do have a different scenario. This is called a piecewise function because we say it has 2 different pieces in it. It has a top piece and a bottom piece. Okay, so, and they really depend on what's happening here with this inequality to the right. All right, notice they also changed the letter. Instead of X, they're using W. Okay, so that's no big deal. All right, so I'm still just going to say, well, this is the W. So first thing I really want to do is look at this information that I'm boxing and comparing those inequalities and saying if I plugged in negative 10 into those W's, I would want to see which one is true. So there's doing both of them. Well, negative 10 is less than negative 3. negative 10 is not greater than negative 3. So that what this means here, so this is kind of just scratch work. What this means is that I want to use the piece that had this true inequality. So I should use the 2w plus 5. Okay, so that's the one I should use. So I'm just going to kind of put that right above on this problem. So that's the one I should use for this step. Okay, so now when we do it, oops, okay, so let me write it a little better. Okay, so I'm going to do g of negative 10 equals, I want to plug it into the 2w plus 5 part, so 2, and then this number, negative 10, is now used in our evaluation, and then we'll add 5. Okay, and then now it's just pure order of operations, so g of negative 10 would be negative 20 plus 5, and then g of negative 10 would be negative 15 for a final answer. Okay, so these problems just require a little bit of scratch work or thinking about before we jump right on in. Okay, so on this next one, this is our new w. So again, I want to plug it into my inequality first just to see which one is true. So negative 3 is less than 3, or negative 3 is greater than or equal to negative 3. And you don't have to really write this down if you don't want to. I mean, you could use your eyeballs and double check that way, but I thought it'd be nice since we're on a computer here to show it. So this top inequality is not true. Negative 3 is less than negative 3 is not true, because negative 3 equals negative 3, and that's where that bottom inequality would help. This is greater than or equal to. So the negative 3 is equal to negative 3, so that means this is the inequality that works. So that means I would want to use the bottom piece. Okay, so again, I'm just kind of marking that up above. So this is g of negative 3 would equal 3, and then plugging in the negative 3 into my w, and then afterwards I would square it. So it looks like that. Okay, so then from here, simplify. So we'd have 3. Negative 3 squared is negative 3 times negative 3, which would be positive 9. And then now we can finish it off. 3 times 9 is 27. Okay, so that's how that one gets evaluated. Okay, this number 3 is a fraction. That's okay. We can still, let's see if we can deal with it. So this is our w in this problem. Again, the w, these letters just are whatever they want to make the letters. So it could be x or some other thing like w here. All right, and then just like before, I want to look at these inequalities. Well, 4/3 is less than negative 3, and 4/3 is greater than or equal to negative 3. Well, 4/3 is definitely not less than negative 3. Positive numbers are not less than negative numbers. So that means I want to use, but this is true, 4/3 is greater than negative 3. Yeah, that's true. Positive numbers are greater than negative numbers. So that means, again, I'm using the 3w squared piece. Okay, so I'm just matching my inequality with the respective piece there for the evaluation. All right, so now I'm going to rewrite it again where I have g of 4/3 equals 3, and then I'm changing that w into 4/3, and then we'll square it. And then we'll continue our order of operations. So g of 4/3 equals 3. 4/3 getting squared. So this happened in the problem above. So the square squares both. Let's go ahead and square both right now. So 4 squared would be 16. 3 squared would be 9. And then now I could also put a 1 under this 3 to help show that I'm multiplying fractions. To multiply fractions, you could multiply straight across and then simplify. Or you can simplify first. Notice that the 3 and the 9 are each divisible by 3. So that means they reduce. So if I divide each by 3, that would become a 1, and the 9 would become a 3. And then now let's multiply straight across. So g of 4/3, 1 times 16 is 16. 1 times 3 is 3. So it's simplified to be 16/3. Okay, and if you're ever unsure about anything, I mean, if we're allowed to use a calculator, plug it in to really verify. Okay, the other problem that we might see in these evaluations is involving graphs. So here we've got the graph of y equals f of x shown. Okay, so and we could put, let me put y equals f of x there. So it's showing, we have a picture of a graph already shown. It says use the graph to find the following: the domain and range. Okay, so this is a recall to the last video. The domain is, let's go ahead and mark it in the black ink. The domain is going from the smallest x value to the biggest. So notice the smallest x value looks like it is negative 3. I'm just going to mark it right there, negative 3. So we'll have negative 3, and because it's a solid dot, starting on the left, we would do a bracket on it. And then going to the right, we have all x coordinates available until we get to, it looks like, positive 3. Okay, and then it's an open dot there. So that means we would do an open parenthesis on the right, just like that. Okay, so that was our domain. And now our range, let's do that one in blue. Okay, so our range, I'm looking at my smallest y coordinate, which looks like it's negative 5. However, it's an open dot, so that means I would use a parenthesis on it. And then going upward, I have all these y coordinates until I get to, up here is the maximum y coordinate, which looks like it is 4. Okay, so that means comma 4. And because there's no dot at all, we assume it's a solid dot, and we'll do a bracket there. There we go. Okay, so that's the domain and range. Now, the second part is to evaluate some functions. Okay, so f of 2, so this is saying that's your x coordinate. So I want to find where my x coordinate is 2. Well, there it is. This is the point 2 comma 0. The function is trying to tell me what this is going to give me as a y coordinate. So it's telling me if I plug x equals 2 in, I get y equals 0. Okay, so that's the x and y. That's the x that goes into the function. That's the y that it gives me as an output. Okay, and let's find this next one. Is number 3 is, let's keep it in green. So I want to find where I have negative 1/2. Okay, so it looks like I'm going to have to eyeball a little bit. Okay, so because here's negative 1. So negative 1/2, I'm going to say, is about there. Well, based on this line of this slope here, based on the slope of this little line segment, it looks like we can make a pretty good guess and say, let me mark this point here, is negative 1/2, and it looks like I'm up 1, 2, 3.5. Okay, so and you could use decimals too if you want. Let's go ahead and use a decimal, 3/2. Okay, so this is the x coordinate that we plugged in, and it looks like 3/2 is the y coordinate it gives us as the output. Okay, and then one other. Number 4 here is find all x values such that f of x equals 3. Okay, so now they're saying this is the y coordinate that they're giving us. How about I use one other actually different color? Let me go back to purple. Okay, so this is our y equals 3. So I want to find where I have y equals 3 on this graph. Okay, so well I have y equals 3 right here. So this is my y equals 3 where I would have my y equals 3 coordinates. So there's one. It looks like I have another y equals 3 right here, and I have another y equals 3 right here. So I have negative 3, comma 3 is the point. This point is negative 1 and 3, and this point is positive 1 and 3. Okay, so I found all of these y coordinates. Let me even highlight it. So that y being 3 is these y's on my graph. And then it's finding all the x values. Well, the x values then, let me use my pink highlighter. The x values are, well, the x coordinates for all these points that we found. Okay, so that means we have x equals negative 3, comma negative 1, comma positive 1. There we go. Okay, so that's how we can use these types of functions to help us. So sometimes we're finding x coordinates. Most of the time, though, we are looking at y coordinates. Here we also use domain and range. Okay, so the main thing when evaluating functions, though, is to use those parentheses. And from there, just be careful with your order of operations. All right, so thanks for watching. If you have questions, please let me know. And I'll see you again soon.